I'm going to give you a tour of our new unit that we just built. Kind of give you a blow-by-blow description of what it entails. So this little guy right here, that's our inlet. So that's where we hook our hoses to our source water. And we bring that in. Comes into the unit. So as you can see, it comes through. And what we have here are a number of sensors. And these sensors, we've got turbidity, we've got dissolved oxygen, pH, ORF, conductivity. We've got flow, and we've got a actuated valve that can control the flow of water. So on the fly, we can test and have this read out what type of water we're bringing in. That's all brought up to these transmitters, and these transmitters will then display everything and actually shoot it up to our PLC panel, which I'll get to in a moment. So this is our draw pump, what we call our draw pump. And this will draw the water from any source, whether it's standing or under pressure. So we can bring that water in through this pump, and this is a 20 horsepower pump, but it's on a VFD, which is a variable speed drive, and that allows us to conserve energy. We bring this water in. Once the water is brought through, what we have right here is a liquid nitrogen injector. So the first one, as you see here, this is all liquid nitrogen. The second one over here is medical grade oxygen. And so the oxygen is brought through these gate valves here, regulators basically. Not gate valves, but they're regulators. So they're going to regulate our flow of oxygen, and the other other oxygen line. The top one feeds this one. The bottom one feeds the one across the way, which we'll get to shortly. The oxygen is generated from way up front, way up here. We have scroll compressors, and those are 2 5-horse, and they alternate so that we have consistent air pressure. And then on the side over here, you'll see we have a dryer which will dry the air down to a -100. That is then injected into this line and into our reactor. And as you can see, this reactor is fairly compact. It's 14 by 14 by 36, but it is a workhorse. It'll process 400 gallons a minute. Once it comes through here, oh, by the way, we have a video monitor and a camera that's inside the box to display exactly what's going on. So you can actually see the event zone taking place. Pretty incredible stuff. Okay, what this reactor actually does, because I'm going to back up a moment here and explain how all of this fits together. The reactor is basically a hydrodynamic cavitation reactor, and the formula for that is velocity times pressure times shear equals cavitation. Now, cavitation is the result of a water molecule going over a sharp edge, traveling over the edge of a sharp edge, and creating a vapor bubble, which increases to 2100 psi and then implodes upon itself to a -15. That creates a hydrogen bomb and heat, hydrogen bomb, it creates an explosion and kinetic energy to 11,000 Kelvin. So anything traveling through this reactor, whether it be a pathogen, organic, a compound, medication, virus, what have you, will be literally destroyed. And as far as particulates or heavy metals, we wind up changing the zeta potential on each of these. So just to explain zeta potential is the act of having a positive, negative, positive charge. So a three-ring charge around itself. So everything has either a double negative or a double positive, accompanied by either a plus positive or a negative. At any rate, we'll strip away that outer ring and allow it to glom onto other particulates of its same nature. Coming through, what happens here, this is we create a vacuum from the time that or almost a vacuum, from the time it hits the shear plate to this point right here, which you can see is about another 3 feet in total. It allows, we go down to a negative 27, which is almost a vacuum. There's no way to achieve true vacuum, but we get pretty close. Anyway, what occurs there is that because of the vacuum, it allows all the particulates to glom onto each other much easier. We have a vacuum transmitter right here that shows us what the vacuum pressure is, and then we have a recovery pressure switch here, not a switch, but just a pressure transmitter. Then what we do have is we go to our next pump, which is another 20 horsepower pump, and what that does is it's a recovery pump. So because we go to a negative, the water becomes static. So we have to regenerate it. So this pump and the draw pump are synchronized so that they'll flow together very neatly without a hiccup. Then we come to our hydraulic separator. And what this does is that mechanically it will dispel or remove all the particulates down to 5 micron. The reason we have this is we want to be able to take this out, all the impurities at this point. This is also has a feature which is a constant backwash, so it cleans itself. So that's what this is right here, and goes into this discharge hose, which in turn comes to here, down, and through the floor and out. The good water will continue on this way to another pressure transmitter, so that we can make sure that all the pressures are reacting the same way and the water flows are consistent. This is the discharge for the bad water. So all the particulates and everything will again be discharged through that 2-inch line through the floor and then out. We have a butterfly valve here that will allow us to control the flow if we need be. So just shooting back here, you can see that in line it comes through, goes through the first pump, goes through the reactor here, then to the second pump, the hydraulic separator, and then into our pre-filter cartridge filter. This side could be completed at this point, so we could call it a day at this stage. Once it reaches this cartridge filter here, we would have drinkable water. So, and a lot of the minerals would remain into this at this point. So, but again, the pathogens, the organics, all the bad stuff would be removed. So, moving on from there, there's an outlet at the very bottom of this tank. You can see way down here. It goes through the floor, comes across, goes through there, and comes up and into this booster pump. So this booster pump is a 75 horsepower booster pump, and comes through, and if you follow the blue line, it goes all the way through to the manifold, and then feeds these 6 reverse osmosis vessels here. We also, if we don't want to run it through there, we can shut this valve off and open this valve up, and now the water would go bypass completely. It come through and then go out the side of the trailer here. So once the water has come up and filled these 6 vessels, it's transferred down like any normal reverse osmosis system, and it comes down all the way through, and then it comes up to the very top 3. So coming back this way, what it does is it gives you the concentrate discharge. So this would be considered our stage 1 brine or our stage 1 concentrate. So what we do is we take that concentrate, it comes down into another MOV, which is another motorized valve here, and then again, here's our another oxygen injector and our second reactor. So we run the concentrate through the reactor on this side. It comes through, comes all the way through, underneath, and up and around and through this pump here. Now, this is another 20 horsepower pump, and now we take this processed water that we've utilized the reactor to process, and we've now brought it up, and it goes into our stage 2. Now, unlike any other reverse osmosis system, most municipalities will only use the white stage or the 1 stage. We're using the 2 stage because we're trying to recapture, and we're not trying, we are recapturing up to 90% of the brine discharge that would normally be discharged in any reverse osmosis plant. Okay, one of the big differences here too is that these membranes are low pressure membranes. So the bottom, the white vessels are a 300 psi range, and the blue is 450 psi range. So little higher, but we're actually pulling more concentrate out. So it comes in, fills at this point here, fills all 3 of these, and then it goes to the end. Well, once it reaches the end, then we have an array on the end here, and you can see that we've got lab cocks where we can test each one of these vessels individually to see what quality the water is, and they also come with a check valve so that none of them are backfilled or contaminated. They're all kept separately. So the top, this is the same way. So all of this is permeate water, and what that means is that's pure water now. It's not. It's beyond drinkable because it's like distilled water, and you don't want to have distilled water. So we have our lines come in for the permeate. This is stage 2 permeate, and you can see if we follow it down, comes down, and this is a conductivity transmitter, so that'll tell us what our conductivity is. It then flows down and connects to this pipe. The manifold here will catch all the white or stage 1 permeate, and that's here, as you can see. Comes along. Here we have a flow meter, and on the concentrate discharge we have a flow meter and a pressure transmitter. This permeate comes down and combines with the stage 2 permeate. Now we have here, what you see is this line that comes in. Well, that's what we call a blend line, and what we're doing is we're taking water, and that would be this valve right here. So we're taking raw water from this side. So right after this cartridge, we're pulling water because it still has minerals. The membranes wind up taking all the minerals out. So this valve will control how much our blend is, and the way we know that, what it should be, is once it reaches this combined, you've got now stage 1 permeate, stage 2 permeate, and combined, and you have the blend line, the raw water. So here we have the same sensors as we have on the front side, and what that does is that'll give us the differentiation between what came in and what's going out. These will also tell us if we need to add more or less raw water. On the stage 2, this is our concentrate discharge. So when it comes out of here, it goes down and comes out of those pipes, and will wind up in this particular cam lock here. This is a 2-inch one, and that'll go into a tank, a cone tank, where it's almost like beach sand, a little sloppier, but like beach sand. So it'll go in and then settle in that tank, and we'll be able to recover that. This discharge here is our permeate, and then that is our waste. If you look up front a little farther, you'll see our the bypass. So moving forward, here's a much better close-up of our compressors. The array, we have a 60-gallon storage tank there, and these are scroll compressors, so the dBs on them are about 70 decibels, much quieter than anything else out there. It'll allow us to at least have a conversation in here without hurting our ears. This up here is our video box. Basically, we've got 360-degree views inside the trailer. So this, we can see everything that's going on in here. And then we also have a 180-degree up top above the door, so we can see everything on the side of the trailer. This is our PLC panel, and this is the brains of this whole system. So as you can see here, we have 3 VFDs, and these VFDs control each of the pumps. So the one here, this one will control that big guy over there, that 75 horse, this one. And then these 2 here operate the other 2 down the side, down there. And then we have one in this cabinet here that goes to this guy. But as you can see, this is our PLC up here, right there. And then we have also we have Ethernet, and we also have cellular capability right here. So we can reach out and go completely mobile, and we can access everything in the trailer here from our iPad, smartphone, or our laptop. So that's pretty much the tour. I hope you get something out of this, and it's great. We're excited about our achievements here, and let's go change the world. Let's go make some water. All right, guys. Thanks.